Hello and welcome to When AI Runs the Stream. I'm Eric Schumacher Rasmussen from Norsk, and I'll be the moderator today. We'll be spending the next hour or so looking at some of the more exciting ways that AI can be used during live events, that it is being used during live events, not only to flag problems or recognize changes in content, but also to act on what it finds. We'll talk about what works. We'll talk about what doesn't. We'll talk about what degree of human oversight is necessary, all with the goal of helping you feel more confident making decisions about how and when to use AI in your own live production workflows. We've got Adrian Rowe from Norsk and JP Saibene from Qualabs, and I'm sure I mutilated his last name because I forgot to ask him the pronunciation before we went live here. And both of them have not only thought and worked long and hard on these problems, but also dealt with the nuts and bolts of putting those solutions into practice. So it's not going to be a typical rah-rah AI discussion. We'll definitely talk about the challenges, problems, and issues with using AI, as well as all the opportunities. Couple of housekeeping notes. You'll notice that the audience chat is open, but please use the Q&A tab at the bottom of your screen to submit any questions. You may need to click the three buttons above More at the bottom of your screen to expose the Q&A tab. Same is true of closed captions. If you want to enable closed captions, if they're not already enabled, you can do so by clicking those three dots and clicking on the captions or subtitles or transcription button. I forget what it's called. Conversely, if you're seeing them and want to turn them off, you can do it there as well. As for questions and answers, once both of our speakers are done, I am going to open up for questions. I will start with a few questions that I prepared myself, but I want to emphasize audience questions over anything else. So if you do have a question for our speakers, please put it in the Q&A tab rather than in the chat. Please don't raise your hand. I'm going to try to keep all the questions in that Q&A tab. And also, if you see a question in that tab that you think you have an answer or a comment on, please don't answer it there. That removes it from visibility, and it makes me very sad. So you can chat with us, though, and chat with each other. And if you have any technical difficulties or other questions that don't pertain to the content for our speakers, you can put those in the chat. So I think that covers all the housekeeping notes. And with that, I'd like to introduce Adrian Rowe, the CEO of Norsk. So Adrian, take it away.
Yeah, thank you very much indeed. Really excited to be here. Right, let me share my screen. There it is, share that one. Cool, hopefully people can see that. So, what was interesting about putting just some thoughts together around this is kind of, yeah, the original question was, what can AI do on a live stream today? And yeah, what can AI do within Norsk? It's just that it's soup to nuts. It's the whole chain. It's building workflows in the first place. It's dashboards. It's creating dynamic infrastructure. It's log analysis. It's AI as a broader topic covers everything we touch upon. But today is all about the stream itself, controlling it, monitoring it, updating it. And I'm going to focus a little bit on the sort of technology side, and I think JP is going to focus a little bit more on the operational side about what that means in practice. Now, having been one of the authors of the original question, I think it's the wrong question. I think it's not about to what extent is AI ready. I think a better question is actually what jobs is it suitable for? It's obviously a moving target, but the rest of the slides here, which will only be sort of 10 or so minutes, explore that space a little bit more. So let's start with some things that I typically even forget are AI under the covers. Transcription, translation. It's kind of a solved problem. So in the bottom right-hand corner of each of my slides, you'll sort of see the Adrian AI index score for a particular area. And translation, transcription, basically a solved problem. Up until maybe a couple of years ago, there was a severe English bias, or certainly Latin languages bias. But that's diminishing today. The ability to target languages right across the world is now much, much more complete. Speech to speech is starting to be a realistic option. So having me commentate on a soccer game or whatever in English and have that simulcast into a whole bunch of different target languages in a way that's not embarrassing, in a way where the emotion involved in that the original speaker provides and so on is now starting to really progress. Some interesting changes just in the last 6 months or so. Organizations starting to build AI sign language translators again. And one of the big drivers behind all of this is now it's increasingly mandated by law. I think in the UK now, to deliver adverts and so on, you have to have subtitling available, and so on. So that fast movement in that space. It's uh, a highly solved problem in the human versus AI space. Um, Kind of the next step down in the tick box list for me is probably monitoring and quality. And there are a few characteristics which for me make it a great candidate for AI interactions. One is the consequence of an AI intervention may well be to get a human being involved. I've noticed that your backup stream for XYZ service isn't looking quite as good as I'd like it to. Let's get a grown up involved. Let's get a human in the loop. So what the AI can be doing is triggering a penalty box action, so that your MCR processes now start to focus where their efforts are best put. And building feedback loops around that is incredibly important, so that if there's a frequent occurrence that frankly you can either automate the response to or doesn't need flagging in the first place, take that as a learning, have it so that over the course of time you're getting fewer and fewer false positives or missed actual challenges. I think another characteristic where we use AI quite extensively is around quality-based switching. So I'll have a live event. I'll be pulling sources from the venue over two different completely separate networks. And I'm going to look at the quality metrics associated with those, be those deterministic qualities like the frame rate, the bit rate, any drop packets, etc., or image quality analysis, where you probably do have AI processes involved, like non-reference image quality analysis and so on. If I decide that one is better than that source B is better than source A, I can probably switch from source A to source B in a way that is entirely transparent to end consumers. So if there was nothing wrong with source A and I switched to source B anyway, chances are nobody's going to miss a frame of video, nobody's going to miss a packet of audio. So the cost of me making that decision incorrectly is typically very, very, very low. And the benefit associated with an AI making that decision appropriately for me is quite high. I've got rain fade on this particular signal, my non-reference image quality score goes down, and so I switch. And suddenly all of my users are getting a better experience without human intervention in a way that revolves around AI. That said, here's a quick screenshot from our Norsk product, which does provides a whole bunch of quality statistics around streams and visual quality and audio quality and loudness and SCSI and et cetera. What we have repeated over here is just this little bit over on the right, zoomed up, of this particular monitor. There's actually only two boxes that relate to AI, and one of them is this one over here, the non-reference image quality sample every n frames. Typically you've either got a compute cost or a token cost associated with your A modeling. I want to minimize that so that it's providing maximum value for minimum compute and or token cost. So you don't need to look at every frame. If a particular frame is bad and then the next one is good again, switching isn't really going to help anyway. And the other one, and the output of it over here is this little number here. There's, I don't know, 70, 80, 90 numbers on the screen. an awful lot of those are deterministic, and I think that's a very, very important model. It's kind of, if you can use maths and or just straight logic to solve your problem, that's typically a better way forward. Where there's a degree of judgment involved, that can be highly AI can be a highly appropriate tool. The next level of kind of state of readiness for me around AI, and where we do have kind of active trials uh, live in the field, delivering live events, is around monetization and event detection. So yeah, it's the classic. I have some tier two, tier three content that, using my standard broadcasting processes, it's too expensive for me to deliver. Um, I can, detect halftime in a soccer match. I can detect time between, when they're changing ends in a tennis match or whatever, and I can inject a Scuddy marker automatically, monetize that stream without the usual MCR processes, without the usual headcount and operational effort associated with it. The other thing that I would recommend really, really strongly early on in an AI trial is try and make mistakes as cheap as possible. So, for example, if I'm doing an entirely automated advert injection, say in my tennis game between change of ends, maybe something like an L bar or a D box setup for my ads going to be more appropriate. Because frankly, if I get it wrong, I haven't completely ruined the user's experience. They can still see the tennis match. It's just a little bit distracting because now it's in, I've got an advert for Coca-Cola or something like that in the right hand side. So AI is great when a little bit like in the monitoring, generating a false switch. AI is great when the cost of making errors is comparatively low. I think one of the things that's really key to understand in that context, though, is what you really want out of your AI interactions is as much deterministic behavior as possible, as much audit trail as to how you ended up making the decisions you did as possible. So here, for example, is uh, just a screenshot from a live soccer match where we're doing automated halftime and monetization injection and so on. What we do is we record every single frame of video that we send up to the LLM. We record the LLM state before that frame of video was sent to it. We record the LLM state after that frame of video was sent to it. So we have a very granular audit trail of, this was our belief of what was going on in the stream as a result of this. We then sent it this extra information. It changed to that. And so you can get some extremely strong reference and quality information so that you can then start to improve and tune and make your AI processes as repeatable as possible. It's the big challenge with AI. It's that repeatability is not what you might necessarily assume. So I think there are three key criteria that I would approach any AI conversation with. It is, can I frame the problem in the most appropriate way possible to play to the strengths of AI? So rather than going, here's a soccer match, there's 12 cameras, I'd like a compelling vision director mix of that. There are use cases where I could say, I'm about to do a Zumba on the beach. I've got 3 cameras. One of them I speak to when I'm explaining the next exercise. One's pointed at my exercise mat where I demonstrate new exercises, and the others of the whole class where I wander around and help people on an individual basis. And at that point, your AI interaction starts to be much, much more constrained. When XYZ is happening, use this shot. When this X thing is happening, use this shot. And you can also script and schedule that to an extent. And if you can constrain or frame the problem as narrowly as possible, you make AI's life is that much easier. Have a little bit of wiggle room. The D box or the D box or L band video being a great example. If my half time, for example, is a few. If my half time detection is 5 seconds late, or my change of ends at tennis again is 5-10 seconds late, doesn't actually matter if I'm inserting a 30-second advert into that time availability. I'm not going to have spoilt the process. So if you can pick processes where there's a little wiggle room. That's really key. And then last but not least, try and find processes where mistakes are cheap. Like, make those mistakes cheap by having your L bar or your penalty box. Design around the miss. And we want to narrow those decisions. Um, don't try and solve unbounded tasks with it because you'll have a very, very poor experience. So now it's really in the more challenging end of the world, but I think it's a nice example as to how you can use AI in various different ways to address some of these challenges. So here we're looking at a 16.9 to 9.16 automated conversion using AI. Well, AI also means a whole bunch of different things. I could be running an object detect model locally and make my decisions about my framing based on that. I might be sending a stream up to an LLM in the cloud using either a traditional interface or using one of the LLMs that supports live stream interaction. Or I might be doing a hybrid. I might be just talking to an LLM in the cloud, but only sending it the object detection locations. And those kinds of impacts have those kinds of choices have very large impacts on cost versus quality versus repeatability that I want to explore just a little bit. So, pick your fight. If I've got an enterprise, AGM or EGM or something that's being broadcasted, and what I want to do is to follow the speaker, that becomes a comparatively straightforward exercise. So if I use a model like YOLO, I can detect who in the frame is currently speaking, and going from 9.16 to 16.9 is a comparatively simple and safe exercise to do that. That comes at a cost. I'm not consuming any tokens with an LLM online, but I am consuming CPU and or GPU resources in order to do that. I could do exactly the same, but hand it all off to an LLM in the cloud, at which point I no longer have compute. I'm not compute resource constrained, but suddenly my token costs have gone up substantially. The other thing that goes up substantially is your latency involved with that, the act of getting it up to the cloud, having the cloud think on it for typically somewhere between 2 seconds and 10 seconds is the kind of latencies we tend to see, and then have it come back. So I'm going to get perhaps a more flexible solution, but one that comes at greater or certainly different cost. I can kind of try and get a best of both worlds around that, where actually locally I'm going to detect all the objects, and what I'm going to do is interact with an LLM because that gives me a little bit more flexibility about behavior and dealing with things I haven't historically thought of. But what I'm going to do is just send up the locations. I'm not going to send the video frames up to it at all, at which point the number of tokens I'm pushing up into that LLM goes down by 2 orders of magnitude, something like that. So I can get very similar results in terms of quality, but at substantially less token cost. And then I can also, certainly in a sort of training mode, we recommend looking for opportunities to mark your own homework. So I'm going to send content up to the cloud, and actually by pushing in the object models whenever I can, but occasionally I'm also going to send the actual image associated with that so that the LLM has both of those available to it. And that's one of the ways you can sit there and start to say, well, yes, we made the same decision based on LLM, based on object location, and based on the LLM processing the image fully, at which point that allows me to start to send the last 10,000 hours of archive material I have through and get some degree of confidence that my process is going to be repeatable and accurate. So for something like 16.9, but as a general strategy, I think a really key thing is pick your battles. Some things lend themselves very well to automation in this particular place. So an enterprise speaker event like we were just looking at, crop to the current speaker. I want that as a good experience on a portrait mode mobile phone. Yeah, that's an entirely solvable problem today. A sport like basketball, follow the ball plus a little bit of momentum in this direction and that momentum, you're going to get an acceptable experience. Something like fencing, not so much. Fencing is an inherently horizontal sport, and what we did though as part of the exercise in how reliable this technology is, we deliberately have explored some areas where we didn't think it was going to perform particularly well. So one of the big challenges is isolated runs can be great, but don't get too sucked into or tempt don't get sold into by that. That can be misleading. Um, Sometimes less so. So here's a nice example where this was the full frame. So I've got the background here with a big poster of two fences. I've got competitor A and competitor B, and then the judge over here. And what the LLM has done in this particular case has gone, oh, great, here's some fabulous action, which isn't a human being at all. It's two people in the backdrop, and it's picked up on that. So here we're failing those kind of criteria where we've got a hard to frame question. The cost of getting it wrong is high, because here what the AI is suggesting we do is focus in on this static content over here that isn't part of the bout whatsoever. One of the things that was also slightly interesting that comes back to the sort of AI as as the thing that helps you build these workflows and orchestrate them in the first place, is this, which is when we set this up, we just said to the AI, here's various Norsk Studio components. This one will allow you to talk to an LLM. This one will allow you to crop and resize the output and so on and so forth. And occasionally it would make decisions that we as humans just hadn't thought of, which was here it's gone, well, the interesting bit's in the center of this, but actually it fundamentally needs to be wider. And so it's chosen to not crop, but to change the aspect ratio to get all of the content in. Now, it's slightly interesting. It discovered that capability, thought it was more appropriate. I, as a human being, hadn't gone there at all. So to summarize, it's what we want is a hard observation on. We want a stream of evidence. We need to minimize the amount of fluffy reasoning that's going on, and we want to be able to say, yes, this came from this piece of evidence, which changed our belief or confidence in whatever it was we were monitoring from this to that, so that we can do some post analysis and start to get higher and higher degrees of confidence around it. Also, question number one is possibly don't use AI where there are algorithmic or deterministic or just straight maths that you can do to solve the problem in a different way. Chances are that's going to be a better experience for you. AI is great for exploration. AI is great for things that are traditionally very difficult. Force yourself to go through that process. And then when we're dealing with online LLMs in particular, try and do as little as possible with them. Try and send them the minimum amount of information that you can get away with, so that they can do their job, because you'll A, it'll be cheaper, and B, your quality is going to be much, much higher as a result. So just to reiterate, for me, it's all about these, the three questions, possibly with a zero in front of all of this. The zero being, make sure that the economics add up. Make sure that you understand all of your costs. Make sure that you understand the impacts of the changes you're going to do. Simply adopting AI because it's cool typically isn't going to end very well. But the things you want to be looking for is ways that you can frame the problem that make the AI's job as easy as possible. Looking for problems where you have a degree of wiggle room, that you don't need this exact frame resulted in this exact transition when you're dealing with live, obviously on demand and so on. It's, you probably can have much more precise answers. And then perhaps most importantly of all, especially early on in a live production use of this, try and make mistakes as cheap as possible, so that if you have put in an automated advert at not quite the right time, you haven't ruined the experience. If you have swapped from one stream to another, that's entirely hitless if you're doing it when both of those streams are happy. And there you have it. With that, I'm going to hand off to JP. More than happy to take questions and so on at the end and see where that leads to.
Thank you so much, Adrian, and thanks, Eric, for the invitation. And it's an honor to be here. So Adrian just showed you what's possible, I think, in these space. And honestly, possibilities are the fun part. So I get to do slightly less glamorous job today, which is to talk about what it actually takes to put any of these into production in front of a real audience and a real budget, without trying to not break anything that's already working. So I'm going to try to make my 15 minutes on the operator side of the conversation, because that's usually our role when we embed in their engineering organizations as Qualabs. So the question is usually not, can AI do this, but more like, because the more and more the answer in the demos is yes. The question I keep running into in clients is can I run this 1,000 times and trust the output every time I run it? And that's a very different question. And that's the one I'm going to try to spend time on. So maybe let me try to start with a map. And sorry, I didn't bring a presentation. It would have been way better. And to keep myself honest, the way I'm thinking about AI in media and the way we're doing it at Qualabs, I need to give a lot of credit to Andy Beach and his Engines of Change work, which has shaped a lot of my mental model. We spent a lot of time discussing about these, and it is that the workflow is the thing that's going to last, but the tools are going to change, are going to weather. So the changes of the stages of our industry do not really change. We still acquire signals, we still switch cameras, we still insert ads, we still monitor for compliance, we distribute, we reconcile rights afterwards, and I think in 2030 we're going to still be doing that, but the models that are doing that job might probably change a couple of times in this time span. So when I look at applied AI across our pipeline, I see roughly the same areas everyone sees: acquisition and capture, live production, switching, editorial, post-production, audio, accessibility, localization or globalization, depending where you live, monetization, broadcast operations, QC. We all see the same thing. But I think the honest version of it, and what I want to put some care is inside every one of those areas that you have to sip, and in each of them, and I think that's to Adrian's point, that he has his Adrian's score. We need to separate what's emerging to what's proven or what's actually a research or demo. And if you don't think about that separation, you're probably going to make budget decisions that are on top of a science project. So my talk is really going to be about that separation and about what it takes to get those NAB or IVC grade demos I trust this into my workflows in production. And so the problem, and I'm going to try to be as plain as I can, is I think we come from determinism, and now we have the black box and the trust. So for decades, our industry has run on determinism. You would buy an encoder, you would set it to 1080p, and the output would be 1080p. You would set it to 60 frames per second, you would get 60 frames per second. And you could take 10 feeds, check the output, and you knew with confidence that the 11th feed or the 10,000th feed was going to behave the same way. So there was usually no magic inside that box. And just as important as that, there was no magic also in the P&L, because you knew what you were paying for, either for the appliance or the per gigabyte, per second of processing, whatever, if you were doing some sort of cloud processing. But now someone's bringing you these solution built on with AI, and things start changing. First, you lose visibility. I think we're not seeing the level of transparency on the architectures and how that's being built. So you don't know where a real deterministic decision is being made and where a probabilistic model is, to say somehow. So sometimes you have a deterministic process, and sometimes you get an opinion, and that's very different, one from the other. A deterministic bag is also repeatable, so our software engineering mindset would make it repeat it, find the pattern, and fix it. But the model that is mostly right fails in ways that you cannot reproduce. So testing is the old way, won't work. And second, we're losing predictability in the cost. In the old world, cost was more deterministic. And I know that that when cloud started, that wasn't the case. But we now know that when we're asking a system to do something, and that's what it's going to cost. But now with these LLMs everywhere, people are asking and asking again and regenerating, and suddenly your chip little clip costed $100 because no one put a quote on that. So the real question underneath all this hype is where is actually AI being used because it is needed, and where is it being used because it is fashionable? And if you can answer that, I can go back to trusting my output. I can say if I run this 1,000 times, I will get a good result with very high accuracy. And that is the bar, in particular coming from broadcast, that was the bar. So, and I think that is the moment an operator will take the hands of the handle bars and let the system steer, and using Adrian's examples. So let me name a trap here, because I fall for it myself every NAB or IBC. You walk into the floor and you see 100 beautiful demos, vertical cat downs, instant highlights, the new telenovela chopped content into shorts for the Brazilian telenovelas or whatever. But everyone looks fantastic, but the demo is a one piece of content that someone chose. And production is a huge catalog that you do not choose. And in particular, here we're talking about live, and it is content that was not produced already, so you don't know what to expect. So the question the demo never answers is, did you preserve a creative intent? Did the system make the choice that a professional human editor would have made, or for the switching? And for the deterministic work, like, yeah, you can check that 16:9 content is now 9:16 cropped, because that's math. And that's easy to verify. But for creative judgment, that's way harder, and we got to train that. So getting to that moment of trust, I think, is the whole game. So I want to talk about a couple of examples of the stuff we're getting into production now. But I must admit that it's not easy to put these systems into production. So one is on the distribution side, like QE, anomaly detection, and root cause analysis when you do large global streaming. So and everyone's talking about this idea at this point, like put an LLM to your QE metrics and go ask it stuff like, how did my game run yesterday? And it's going to tell you like, oh, I find some weird 404 errors or something. But that's a nice demo. But that's not the system and operations team can run on a live event, because that's not the kind of questions and their workflow. So looking at how we run it during the real operation, we built it as a funnel, and the funnel is the point. So there's a layer for pure detection, like, is there something wrong? And there is a threshold held over sliding window. No, there's no AI there. It's sometimes you get answers like, yes, something is off, and there's a second layer, like, about why, but only for causes that we've seen before. If it matches an anomaly that we've seen against known patterns, then there's a deterministic answer, like, oh, this is a potential root cause. There's no LLM there. But then there's a third layer, and here's where the AI magic appears, and it only runs when the first couple of layers didn't find something that was proven before to be a problem. And this is potentially a new cause. So the model is going to do the one job a model is actually good at, which is reasoning over something open-ended that we have not codified yet. And now here's the part that I'm super proud of, because the answer is to how do we build trust that I was talking before. When the LLM does explain a new cause, the system does not move on. It proposes that explanation into a pattern, and the human engineer that has the experience looks at it, and if it's right, they approve it. And from that moment on, that same incident is diagnosed instantly in a deterministic way. without ever touching an LLM again. So we're using the human in the loop not as a safety blanket, but as a mechanism. We're using the human to turn magic into determinism, one incident at a time. The system gets more deterministic and also cheaper the longer it runs. And one more thing, because it matters, we did not hand these engineers a chatbot or an MCP. What we did was like level 2 engineers already live in runbooks, and that's how they operate. So that's how they are operationalizing their knowledge. And so we build the system that way because that was the artifact they already understood. So the lesson here is that the hard integration in this case was not into the media workflow, it was into the human workflow, into the real business or engineering process. And we have a second example in which we're also working, which is, and Adrian talked about these highlights, clips. But talking to one of our clients, they came with a real problem, and they have a lot of vendors coming with a new AI highlight generation tool. But the problem is that now choosing the tool becomes a human problem, because you need to evaluate the output of that cropping or that highlight for every clip, and you got to do it manually or human based. So the trap of generative AI, and I think we've all experienced that with the emails and presentations these days, is that your generator can create thousands of clips, but someone now has to go and check that. And so we didn't remove the bottleneck. I think we moved it from generating to QC to validating. And so we're not building a generator, we're building a validator, which is the QC layer that honestly nobody has bothered automating, or at least not that we know of. So you give it a clip and a spec, and it gives you a score, like, yeah, you can publish this or you cannot. And again, it is a hybrid on purpose. There are some deterministic checks. As I said, the vertical cropping, we can do the math, and that's deterministic. But and checking whether a logo is present or not, we knew how to do that before. We don't need an LLM for that. But there are some semantic checks that handle judgment, like is the sponsor actually visible? Is there a goal in this game? Is the commentary consistent with the play on the screen? And I think there's where the LLM earns its place. So the durable value here is not in the model, it's in the orchestration. Adding a new check tomorrow or a new sport means giving the agent a new tool, but not rewriting the entire pipeline. So, and again, I want to be super honest about the maturity, because that is the whole theme of this conversation. This is still emerging. It's not proven. We haven't seen it working and running a lot there, but I think we're going to get there soon. So we don't have our formal requirement list because the market's not ready yet, but what we get is defined a criteria ourselves, and we build it on some data sets to test against. And that brings another conversation, which is training data sets and synthetic data, but I think that's not today's conversation. So what we're doing with these tools is trying to differentiate between this. It looked great in the demo, and yeah, I can tell your own detection rate. So if you take the idea between both examples, and these are just two examples, the value is not in the model. The model is the weather. I think the value is in the orchestration, in the media-aware context of the system reasoning against. And to borrow Andy's line, again, if you let a vendor own that agent layer and you do not own the context underneath it, you're going to end up renting your own workflow back from your suppliers. And we've seen that before. So let me close on the two things that actually decide whether these projects live or die, and neither of them is a model quality. The first one I think is going to be unit economics. I said it earlier, but it is the thing that keeps operators up at night. We went from a world where costs were more deterministic and could forecast, and the world where consumption is open-ended and hard to model. So part of being honest with the clients is telling them we have to design for cost, cap it, make the expensive path, the LLM path, the exception on the default, because that's only great for demos. And most systems I showed are built that way. And also the second is the human question, and I'll bring it about. I'll try to be straight about it, which is there's a lot of pressure right now. Not of it's coming from the finance side to cut a big number and figure out how AI is going to do it later. And I don't think that's how good systems are get built. The teams that will win are the ones that figure out where AI genuinely earns its place, where determinism is still cheaper, more accurate, and more trustworthy, and how to keep the human in the loop in a way that makes the whole system smarter over time instead of just cheaper this quarter. So my ask to everyone here is let's try to be honest on the pitch. Do not sell it like magic and do not buy it like magic either. I think we as an industry need to find places where AI is genuinely the right tool and prove them against real ground truth and build the human into the design. So that's mostly where we're spending our time at Qualabs these days. Eric, back to you now.
Yeah, thank you very much, JP. And Adrian, why don't you join us again on camera? Let's all be on camera at this point. We don't have any questions from the audience yet. Want to remind you, if you do have questions, to put them in the Q&A tab at the bottom of your screen. You might need to click that, those three dots above the More button. But I want to start the discussion with something you raised, JP, and then Adrian, you should certainly follow up. You said, and I think it's a great point, that for 20 years, this industry has run on determinism. You get an encoder, you set it to 1080p, you're going to get 1080p every time. And that AI breaks that in two ways. You lose visibility into what the box is doing, and you lose cost predictability. Let's focus on the first part of that first. How does an operator, an engineer, trust a system where they can't always see where and what AI, they can probably see what AI is deciding, but maybe not, versus where deterministic engineering is happening?
That's a good one. And I think we had the same challenge when we moved towards software at some point. And I think you need to start by refusing to accept the black box. Like if the system has to be, I think that the system has to be honest about the internals, and we as vendors needs to be honest about what we're building. So in the systems we build, AI is not like sprinkled everywhere. It is specifically isolated, and there are some decisions that actually need judgment, and everything else stays deterministic and inspectable. So when something goes wrong, I can tell which part made the call. And the second part to it, I think it's make the AI show its work. Like, and we see that when we use any co-work tool that tells you the steps and the plan. So it should not just hand you an answer. It should hand you the evidence on the reasoning and the thought process, so that humans can check against it. And the third thing, honestly, I think it's trust is earned incrementally. So run the AI next to humans first, and only when it's proven itself against real use cases, then let it run on its own. Trust it. I don't think trust is a switch we flip. I think it's something we earn.
Yeah, completely agree. I mean, I think one of the biggest challenges of AI as a science is that it you get to consume the what's. Yeah, you get to, as in what the AI has told you. There is progress being made on it, but the why, the reasoning around why it makes a decision, or why it thinks XYZ is an appropriate action as a result of that is still very much emerging, and it tends to also technically be done post the fact. They'll make a decision and then they try and kind of post justify it as a second stage, and in a live environment, the kind of latency that introduces, and not to say the extra costs and so on, come out that can be very hard to justify. And then and in fact, many AI people would say go the opposite way. And some of the early work done, beating Go as a game, which is kind of one of the first, this AI humans were never going to be beaten type things. What was interesting is that the first project on that started life by teaching it all the rules, and chess before that was very much here's 100 million games that and here's how they all came out. So learned from that. Whereas increasingly, if AI works around an ability to create and mark its own content. If I can play a bazillion games of Go, then actually I don't even need to know the rules of Go. I can sit there and just place things randomly, and then I get some kind of score, and then I can generate new content, and I can generate better scores, and I can generate new content, and I can get better scores. And so AI purists would say actually don't try it. The why isn't important. I think emotionally the why for me is extremely important. Why did XYZ happen? I want to be able to rationalize that. I want especially when it was the wrong decision. I've got a customer here that wonders why this particular speaker was never tracked. That's going to be very important to them, or why we were always 2 seconds after the football in the auto 9:16, 16:9 conversion, etc. I think the other thing to say, I think just echoing what JP was saying about it becomes an exercise in validation. I think that's exactly correct. And I think there aren't that many options yet, other than where there has been some interesting work is to get an expensive AI to validate the work of a cheap AI. And that's how actually a number of more recent AI LLM providers have been able to go from zero to hero incredibly quickly, and at the cost of only $100 million rather than XYZ, but tens of billions of dollars and so on. So economically, if what you're looking to do is to use AI to produce or to monitor your tier 3, tier 4 sports event, because doing it with a human being would be too expensive, having to run 100,000 hours of content through an LLM to work out that it's all good beforehand is a complete and utter non-starter. And so I suspect that also inevitably it's that emerging trust type relationship where initially it's going to be human in the loop. You then try and make it a less annoying process over the course of time by refining the prompts, by using neural models, by introducing determinism wherever you can. And then over the course of time, when it's actually my error rate now without involving a human is the same as what it would be or comparable to what it would be if it were just humans doing it, then I'm probably in an acceptable place, so long as the economics still stand up. That's look at those token counts. Context is king. Context is king. Context is cost. Too much context is poor quality, and those are things you really want to hone in on when you're looking to make what makes for an appropriate challenge for an AI to be doing in a real live stream that people are going to watch.
You both mentioned cost a little bit, but most of your answers were focused on trust on the engineering side, on the what it does side. How can we bring some sort of trust into cost predictability? How have either of you been able to better understand putting the costing together for an RFI or RFP in a way that your clients feel like they can trust you and they can believe what you're saying without the asterisk next to the number?
JP, do you want to go first?
I can go first, sure. And I think the honest answer is that you need to design for cost predictability from day one. Like, you don't discover it in the invoice. Like, the single biggest move is to make the expensive pass, as I said before, the exception, not the default. And And then like the anomalous system, I mentioned the LLM only fires when you have a new problem. That's one case. And then you put the hard caps and the budgets into the architecture itself. So and I think we learned that from the migration to the cloud too. Like let's not do it and then figure out the costs. Because I remember walking around clients' offices and they had big screens with their cloud costs month to month because that was their number one KPI. How can we cut down costs? Because the magic of a cloud was becoming super expensive. And I think you got to be honest with the client. Like consumption is now variable, and you got to and you influence with how you use the system. So the same way we do with a cloud compute. So the old encoder that would fixed and predictable, that this isn't. Like you need to model it, you need to cap it, you need to communicate it, and you need to design so the economics get better with usage. So I think we need to stay close to the process so that we understand not only how the system achieves what it needs to achieve, but also how it is used so that we understand how the costs scale.
Absolutely. I think the comparison to early days of cloud is a strong one, where I think most customers had a sort of naive. They would go, all right, I need 200 servers in the cloud. They're of this type. They're going to cost me whatever it is, $2 each. Therefore, it's going to be $400 an hour. And we would always go, no, you really need to model this, because actually, as a rule of thumb, that's probably at most half of your cost, because you've got ingress and egress, and then it depends on what's happening over here, and storage, and what's your long-term policy, and so on and so forth. There's the devil is in the detail, and I think that's where looking at hybrid approaches, where I'm not sending the image to an LLM, I'm sending the location of all the objects to the LLM, can actually have dramatic impacts. I mean, order of magnitude, maybe even 2 orders of magnitude in terms of token usage. And bizarrely enough, you can end up with higher quality results as a consequence. So not only is it going to be vastly, vastly cheaper, it's also because the LLM's not having to reason about stuff that frankly isn't very relevant to the problem, and that's incredibly hard for it to decide itself. You can end up doing that. But I think you have to treat cost as a first-class citizen in this. It has to be one of the absolute headlines. Yeah, frankly, people do, but well, actually, I'm not sure everybody does. I think a lot of people go, it's AI. There was an ad during the football last night. I shouldn't have mentioned the football, but there was an ad during the football last night where I think the AI was like said every 5th word or something, that this particular service will AI or AIs and coordinate all the AIs and so on and so forth. And it's just, that's just asking for people to lose control of their own projects, asking people to lose control of their own economic models. Start with and it's not always that it obvious that it delivers what the goal of the project is. If you're looking to monetize tier 3, tier 4 content, if I'm suddenly paying $10 an hour per stream, to hand it all off to an LLM for quality analysis or something along those lines, and I've got 200 of them, that's probably going to be about as expensive as my human being type process was. So, no surprises, please.
Right. I want to move down. We've got a couple minutes left. Move down from the higher level to sort of a lower level. As you have both implemented AI within your systems and AI systems to manage other systems, et cetera, with things like, Adrian, you mentioned, graphics placement, Scuddy marker insertion, and the like during live events. What sort of surprises have you run into? What has been unexpected that you have really learned from, and that you think that perhaps our attendees could learn from as they're doing their own thing, so they don't make the same mistakes? It maybe wasn't a mistake, but it might guide them in a certain direction.
I'll go briefly, and that thing we showed with the fencing, and because the way that was put together was, dear AI of choice, here's an MCP that shows you what Norsk can do. Here's an MCP that describes the services that this cloud provider can give to you. Let's go through an iterative cycle where we construct a a prompt, manage state, go through a kind of mark your own homework process on that, and so on and so forth. And because of the discovery, it finds capabilities of tools within the tool set you give it that you wouldn't necessarily have reached for yourself. Because the LLM's just big, probabilistic machines that try things and see the results, and then iterate through that over the course of time with a high degree of patience. So I think there are a couple of times the way it built a solution, or to something is absolutely not necessarily the way a human being would have done it. And actually, occasionally that's better than the human being would have done. It's just, they don't think like human beings. They think like probability machines. So, and that's that's both an opportunity and a risk, because, things that strike it as obviously correct might strike a human being as obviously incorrect, and vice versa. So, yeah.
JP?
Interesting. And I think if I were to add there, there's several lessons learned from our team, but I've seen that also in our internal adoption too. It's never about the model. It's always around the edge. And I think one of our early mistakes was like we need to separate R&D from production systems. And because when you do R&D, you design from the technology, but when you do products, you design from the operator perspective. And we could build something super clever that then be surprised it didn't get adopted. And there's a reason that's always the same. We hadn't designed it for the human workflow, for the people actually using it. And so what I said about the run books, like that was how they operate, like how they operated before and how they had their knowledge, run books. So the moment we stopped handling run books, then a new tool appeared, but it was also, they had to learn and adapt not only the technology, but now also their processes around it. So I think change management is a big lesson here. So I don't think we need to ask the operator to adopt AI. I think we need to make AI producing something that already fits within the operator's workflow.
Makes sense. And we're coming up on time here. Thank you, JP. Thank you, Adrian, for your presentations and your discussion afterwards. Thanks to everyone who attended. This webinar will be available on demand within the next week or so, and you'll get an email when it is if you want to watch again or share with colleagues. Once again, we appreciate your time, and we'll see you the next time.
Thank you.
Take care, everyone.
Thanks, everyone. Bye-bye.